The Soufriere Hills volcano on the Caribbean island of Montserrat started a dramatic eruption in 1995. Plymouth, the capital of Montserrat, was destroyed by the eruption. Thousands of people had to abandon their homes and leave the island. This film tells the story of the eruption. You'll see great spectacles of nature, including growth of a new mountain of red-hot lava, deadly flows of hot volcanic ash, and dramatic explosions. The film explains the scientific methods used to study volcanoes. Montserrat lies at the northern end of a chain of islands called the Lesser Antilles. 11 of the islands are active volcanoes. The island of Montserrat is 16 kilometers long and 9 kilometers wide, with the Soufriere Hills in the yellow area in the south. Montserrat is a British overseas territory. Before the eruption, about 12,000 people lived on the island. The capital of Plymouth was the center of a thriving island society with a successful economy. There was a rice mill, several cottage industries, and a reputation as a friendly and relaxed place. The island attracted many visitors and tourists. The best farmland and most places to live were on the flanks of the volcano. The Soufriere Hills volcano consists of several rugged peaks made of lava from prehistoric eruptions. There had been no eruptions in historic times. Such a sleeping volcano is said to be dormant. Volcanic processes have shaped this beautiful landscape, forming the island out of the sea in countless eruptions over millions of years. Why are there so many volcanoes in the Caribbean? The answer to this question is plate tectonics. The Earth's surface is broken up into plates, and most of the world's volcanoes occur boundaries between the plates. Where the plates move apart, a ridge of volcanoes forms on the ocean floor at the split in the Earth. Where the Atlantic plate collides with the Caribbean plate, the Atlantic plate sinks into the Earth's interior, causing rocks to melt and form a liquid called magma. Magma collects in a magma chamber below the volcano. Magma then moves from the chamber to the surface and erupts. For 3 years before the eruption, there were many earthquakes beneath the volcano. The earthquakes are recorded on seismometer in the observatory. Earthquakes are common on Caribbean islands, so nobody realized that an eruption was going to happen. Earthquakes are caused by magma breaking rocks as it pushes its way to the surface. In July 1995, clouds of steam in the crater signal the start of the eruption. In a tropical island, high rainfall soaks the inside of the volcano with water. The water boils, and jets of steam rush out of the ground. Sometimes the heated steam explodes in the crater. The magma reached the surface inside the crater in November 1995. An unstable pile of lava called a dome began to grow. The lava on Montserrat is calcite and is typical of volcanoes where tectonic plates collide. The lava is very stiff and cannot flow away from the vent. The lava dome gradually grows to form a new mountain. Let us now compare andesite lava on Montserrat with a volcano erupting basalt lava. Basalt lava is very fluid and gases escape easily. Spectacular lava fountains form and rivers of red-hot lava flow across the volcano. Andesite lava is very stiff and cannot flow easily. At night, the red-hot lava glows. The lava is very unstable, and bits break off and roll down the side of the dome. Let's now go and look at pieces of the andesite lava.
I'm in Plymouth, and I'm looking at a lump of the lava dome which had been brought down into Plymouth by pyroclastic flows. And I'm here to show you what a volcanic rock looks like from such a lava. The lava is mostly made up of liquid rock, but also contains quite a lot of black crystals that you can see here, which formed in the magma chamber at about 850 degrees centigrade, 5 kilometers below the Earth's surface, before the lava erupts. So magma is a mixture of liquid rock and solid crystals.
By April 1996, the dome formed a small mountain. A new and deadly phenomenon started. Large pieces of the dome fell off, disintegrated, and formed avalanches of hot lava fragments and ash. These avalanches are known as pyroclastic flows and are the most dangerous kinds of volcanic phenomena. Pyroclastic means literally hot fragments and is the scientific term for all fragments erupted by a volcano, from rocks the size of a house down to fine dust. As the pyroclastic flow moves, the hot rocks bounce and collide. Huge amounts of small particles and dust, known as volcanic ash, forms. There are also hot gases which expand in the pyroclastic flow. A fearsome, turbulent cloud of ash and hot gas rises above the pyroclastic flow. The avalanche, with lots of big, hot lava fragments, moves down the valley. But the hot cloud of ash and gas can also rise over hills. Nobody can survive such terrible flows, which can move at speeds of over 100 kilometers per hour. They burn and destroy everything in their way. Some of the ash and hot air becomes so light that it rises as a cloud several kilometers above the volcano. As the dome increases in size, the pyroclastic flow tends to get bigger and travel further from the volcano. By May 1996, the flows moved all the way down the valley to the sea to the east of the volcano. You're now watching some of the most dramatic film of the eruption as pyroclastic flows move into the ocean. The pyroclastic flow moves in the sea, and the cloud of ash and gas above the flows cross the water. Small explosions occur as the hot pyroclastic flow mixes rapidly with boiling sea water. A new area of land formed off the east coast of Montserrat and extended the coastline 600 meters out to sea. This is one of the main processes that formed the islands of the Caribbean. Countless eruptions over millions of years gradually built the islands out of the sea, with the islands expanding each time there is a major eruption. By June 1997, the dome had expanded to fill the entire crater. The new mountain towered above the crater rim, and small pyroclastic flows moved down the valleys on the flanks. Much larger flows were soon to come down this valley. A terrible tragedy was to take place. The farmland to the north of the volcano had been officially evacuated, but farmers returned to this dangerous area to work and look after their crops. Pyroclastic flows were forming as the farmers worked in their fields. On June 25, the dangerous state of the volcano was making everyone nervous. During the morning, intense earthquake activity was recorded on seismographs in the observatory, with an earthquake every minute. At about 1 o'clock, 10 million tons of lava collapsed off the dome. A pyroclastic flow swept over the northern flanks of the volcano at a speed of 100 kilometers per hour. Hot clouds of ash set many houses on fire. Tragically, 19 people lost their lives. There was little chance of survival. Helicopters searched desperately and rescued people trapped on the volcano. Let us now listen to the experience of a survivor.
I heard the siren and I got up from the table and I said, something must be happening. I went to the back of the house, opened the door, and I looked up at the volcano because I would be able to see the dome from where I am.
My God.
So I looked up, but I did not see anything because it was very much overcast.
Mm-hmm.
So after I didn't see any ash or anything, I decided to go back and continue working. While I was there, I heard a horn. And when I looked out, it was my son. He's a police officer. I saw this police transport. And he just jumped out. I said, Mom, come. A pyroclastic flow coming down up here. Come, get out from here. So I just dashed through out of the shed into the house, grabbed up my bag inside the bedroom and a pair of shoes. That's all I took.
In August 1997, the volcano became increasingly active with some spectacular explosions. Much of the island was now under threat. A volcanic explosion is caused by the gas dissolved in magma at high pressure deep in the earth. As the magma hits the earth's surface, gas bubbles form and are trying to expand. However, the stiff andesite magma resists the expansion, and so the pressure in the magma remains very high. The magma explodes, breaking itself apart. The gas expands to reach an incredible speed of 700 kilometers per hour, close to the land speed record. Rocks with the weight of a car are hurled over 2 kilometers. Some of the exploded mixture collapses as a huge fountain because it is denser than the surrounding atmosphere. Another kind of pyroclastic flow forms, which contains lumps of pumice as well as ash. Pumice is volcanic rock full of gas bubbles which form before the explosion. The exploded material mixes with lots of air which is heated. A cloud of hot air and ash rises to heights of several kilometers above the volcano.
apart from lava, volcanoes, when they explode, erupt a different kind of rock. They erupt a frothy rock which is called pumice. And what happens is, as the magma comes near the Earth's surface, the gas dissolved in it puffs up the magma and forms a foam with lots of bubbles. And you can see that this lump of pumice has some quite big bubbles in it. And when a lump of pumice is put on water, it very often will float. As well as the pumice, when you get the explosions, you also form smaller particles. You form the fine particles which we call volcanic ash, like this material.
Clouds of pumice and ash are blown over the island by the wind after an explosion. Pumice and ash rains out of the sky. During an ashfall, the sun is blocked out and the day turns to night, making driving conditions very dangerous. Everything is covered in grey ash.
I'm in downtown Plymouth to show you the effects of volcanic ash and pumice when it falls out of the sky from a volcanic eruption column. In the case of Plymouth, the volcano up there produced great explosions and ash columns, and the wind blew the ash over Plymouth, draping it in volcanic ash and pumice. Now, of course, a lot of the ash and pumice lands on the roofs of houses. And see, in the middle of Plymouth, about 30 centimetres of volcanic ash is deposited on this roof. Now, that can cause problems because sometimes the roof is very weak, and if the roof is weak, then the loading of the volcanic ash can make the roof fall in, and this is really a very serious hazard on active volcanoes. Another hazard is that the ash from a volcano often contains a great deal of very fine dust. And this dust can cause health problems. People drive their vehicles through the ash, or they can try and clean off their roofs, and this can cause serious health problems.
At the end of 1997, the volcano was dangerous and unstable. A devastating eruption was expected and threatened the village of St. Patrick's, which had been evacuated. Predicted eruption occurred December 26, 1997, causing a dramatic change in the landscape. The dome collapsed to form an exceptionally violent pyroclastic flow. Moving at over 300 kilometers per hour, the flow devastated 10 square kilometers of southern Montserrat and completely destroyed the village of St. Patrick's. The flow was so energetic that it flowed over the mountains, scarring the landscape and destroying everything in its path. Such a terrible flow is sometimes known as a volcanic blast. Let's now go and visit a house destroyed by the volcanic blast.
You can see in this house that the whole top floor of the house has been stripped off by the pyroclastic surge. You hear a pillar that's broken off, and you can see the bits of debris from the top floor have been strung out downstream of the house. And now we're going to go back and look at behind the house, where we can see some impact structures. We're at the side of a house which is affected by the 26th of December pyroclastic surge. The surge picked up boulders, and these boulders impacted the wall of the house. Mostly they bounced out, but in this case a big rock has actually implanted itself in the wall of the house, and in fact the whole upper floor of the house has been swept away, and you can see these impact marks from boulders from the surge. We can now go into the house and see what happened in the dining room. So going into the dining room, surprisingly, the table's almost set for dinner. There's been no disturbance, and all that's happened is a lot of ash from the surge has come into the room and spread over the room, but you can see that the dining room is pretty well undisturbed despite the mayhem outside.
Volcanic eruptions cover the land with huge amounts of volcanic ash. There is a lot of rain on Montserrat because of the tropical climate, especially during the hurricane season. A major hazard occurs when rivers swollen by rain mix with the loose volcanic deposits to form a lahar or volcanic mud flow. A lahar is a rapidly moving mixture of boulders, ash and water. Lahars can be very destructive and dangerous. During the eruption, the center of Plymouth had been devastated by many lahars. Many buildings have been buried in lahar deposit. The main tasks of scientists on a volcano are to monitor the activity, identify when the volcano is dangerous, forecast when eruptions will happen, and advise the civil authorities on the hazards and risks. The civil authorities then decide when to evacuate people from places that have become unsafe. We are now in the Montserrat Volcano Observatory, which is the building where the scientific team works and monitors the volcano. Let's now find out about the scientific methods of monitoring volcanoes. There have been over 10,000 earthquakes every year on Montserrat since the eruption started. An instrument called a seismometer measures the vibrations of the ground, and these measurements are recorded by a seismograph. The movement of the pen mimics the vibration of the ground. Earthquakes can be studied by a scientist in the same way that a doctor uses a stethoscope to listen to the breathing inside the volcano, which helps recognize when the volcano is becoming dangerous. When a volcano erupts, the pressure inside increases and makes the sides of the volcano swell. You cannot see this, but the instruments can measure the distance between two places very precisely. Changes of only a few millimeters over distances of several kilometers can be detected. One instrument measures distance by reflecting laser light off mirrors on the volcano. Another instrument receives signals from satellites to determine exact positions. During the eruption, the Soufriere Hills volcano swelled by several centimeters. The gas in a volcano is mainly steam. There is also some sulfur dioxide and chlorine, gases which can cause acid rain. The amount of gas escaping from the volcano can be measured by instruments which detect gas molecules in the atmosphere. The instrument is pointed at the sky above the volcano, and the instrument measures the changes in the light energy coming from the sun due to the presence of volcanic gas. The impact of the eruption on Montserrat has been considerable. As the eruption escalated, increasing areas of Montserrat were threatened and had to be evacuated. The economy collapsed as key infrastructures such as the port, airport, and rice mill had to be abandoned. The scientists used observations and understanding of the volcano to make hazard maps, which helped the authorities manage the crisis and make difficult decisions. Scientists also met the public to explain what was happening on the volcano. The island was to accommodate all the displaced people. Many Montserratians had to leave their homeland or had to live in primitive shelters. By 1999, 4,000 people of the original 12,000 population remained on Montserrat. Those remaining are determined to rebuild the island society. Volcanic eruptions cannot be controlled. Progress in understanding volcanoes can help societies be better prepared to face erupting volcanoes and reduce the damaging effects of volcanism.